So now I want to start the course for the first topic. I hope you guys I hope you guys can be ready. Okay. So basically today is just about introduction. It's nothing. The It's just about just about introduction. I'm not saying it's not important, but I just want to say that this is something that you need to understand before we start the biostatistics. Okay. Again, now we're talking about biostatistics. The key here is statistics, but there is one component of biology here. So biostatistics is basically statistics that oftenly used in biology. So if you want to study statistics in mathematics, you have different type. It's exhaustive. So I myself cannot how to say. Uh, it's very hard for me also to get to understand everything about statistics here. But what we are concentrating here is not in this course is just looking at biological statistics. You may found that some of the information or some of the knowledge here you already know. But what we are trying to do is to give some idea on how the statistic is used in biology. And of course, most of you will use it during your final year for your final year project. So especially for those who are in ecology, for those who are using experiments, you want to do some how you want to interpret your data. So you need to have some basic idea or some basic knowledge about in biostatistics. So basically, it's about maintaining data. It's just about playing with the data. So you need to collect data and then how you want to interpret the data. That's biostatistics, data in biology. Okay, so a lot of things that about information about what is data. I hope by now you know what is population, what is sample, what you call it census, what is called as parameter, what is called as observation. So this is something the terms that you will discover throughout this course. So I hope try to browse through and then try to understand what does it mean by data or all these how to say how all these terms. Okay, so some of it are like observation. So what we call as observation is like an individual value of a variable. Okay, some like you have a body weight, you have this variable height, you have this, you want to measure the biomass, so you need to have the observation. So the value of, let's say, the value of the weight, yeah, from like this, especially like 60 kilogram is an observation. So 60 kilogram is an observation. So sometimes, and then we also have a quantitative variables where the data that we can measure or count it. So some that is what means by quantitative variables. Another one, what we call as variables, is continuous variables. This one is, if I can read to you, is data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. Okay, so there is a which means that uh, it's a continuous. Okay, you can count 1, 2, 3, and 4. So that's a discrete 1, 2, 3, and 4. So you have 5 fingers. Okay, but in terms of length, okay, the distance between my fingers and this fingers is a continuous. Okay, but if you want to know how many fingers I have 1, 2, 3, 4, and 5. I cannot say that I have 4.5 fingers. Probably yes, but I think it's quite possible. Or I can say we want to count people. We have 2.5 people. So how? There's one because the half people we cannot count as a people because there's a ghost already, right? Walking around with no head, so we cannot count as a one. So that's discrete. So another one is continuous variable. Another one is what we call as inferential statistics. So this is a process of making inferences from a sample to a larger population. So we want to uh, uh, make assumption. So we need to do sampling. So we want to do estimation. So this is what you call as inferential statistics. So basically, we gather the data from big or from a small from a small sample to make inference for the larger population. Okay, so make a generalization in a way. So these are the some of the terms that you need to get familiarized throughout the course. Of course, I cannot. There is a lot more other terms that you need to understand and then to try to basically try to understand and try to memorize. Okay, try to remember. Try to get familiarized. Okay, that's the term that I want to look at. So again, statistics is about, like I said, you have a descriptive, you have the inferential. So basically, there's directly you can count descriptive for 1, 2, 3, and 4. We have certain data. So some of inferential where you need to do some collection of data sampling, for instance, to interpret a bigger population, or to interpret the whole population. So you have two techniques here to understand. One is a quantitative, and another one is qualitative. Okay, so in statistics, measure in biostatistics, especially in biostatistics, mainly we focus on the quantitative rather than qualitative. Okay, we don't talk about the statistic of the emotion of students. So something that we cannot measure by values, right? So we're talking about the height of students, the weight of the students, something like that. So you have the quantitative, a number of plants, for instance. So, and then in quantitative, you have two, continuous and also discrete quantitative. Okay. One thing that I really want you to guys to explore a little bit is these four terms of scale. Okay, which is a nominal, ordinal, interval, and ratio. These three type of measurement scales. Okay, I think this is important. Whenever you want to do a statistic, you need to understand these four terms: nominal, uh, ordinal, interval, and ratio. Okay, what's the difference? So what are they? Okay, so nominal scale is basically when you want to characterize by data that not consists of any label or any categories, and then they don't have any order. For instance, your gender. What is your gender? Is a male or female? You cannot order a male first, female second. No. Okay, there is only two gender, male and female. Your what else? Your eye color. Is it your blue or your brown or your black? Hair color. So you have, so you don't have order. You don't have white or to black. So that you don't have order. You just kind of like scale. So you get A, B, C, or D. Or can I say that? Or so they have an order. Sorry, so there is no order. So you can have fail or failure. So like say something like that, or success or not success. What else can I say? That's the nominal scale. So something that you don't have order to that character. Which school that you go, what university that you are going, which university that you study, what faculty you are, so what department are you? So that's on nominal scale. Okay, that's first. Next, when you have order, like the level of happiness, like when you go to airport, when you go to customer service officers or counter, you have please rate us. So you have the smiley face from sad to happy, right? So you have, so when you have this order, so then when you have this arrangement, so then you go and then you can go. That is what we call it as ordinal scale. So when you do the survey, adakah anda you agree or agree, neutral, strongly disagree, strongly agree, neutral, disagree, strongly disagree. So that you have order. So this is something that we call it as a ordinal scale because you have a rank order. Okay, the next part is interval. So like sorry, excuse me. Okay, like the ordinal, interval scale also have uh, order. Okay, so what but the order has the order has value. Okay, for instance, there is a one uh, one value to one value. So scale. So apa like uh, how to say it? One arm to one arm. Okay, so that's you have scale. So that's you have the interval scale. Okay, the most common type of the interval scale is what we call as a temperature. Temperature is always a temperature is a interval scale where no natural zero. So they have, when I say no, because they have no starting point. For instance, as a temperature, temperature has when you let's say in Celsius, yeah, temperature in Celsius, okay, temperature in Celsius. What you call as temperature in Celsius is when you have a degree Celsius. So when you have 0 degree Celsius, it doesn't mean that you don't have zero temperature. You know what I mean? Let's say you want to count a temperature as a heat. So zero is not, it doesn't mean that there is no heat, because -1 and -2, for instance, which one is hotter? -1 or -2 or -1? So -1 is relatively hotter than -2, which means that although they have the negative values, but it doesn't have a natural zero. What means by natural zero is when you have, let's say, height. Okay, when you have height, you have 0 centimeter. 0 centimeter means, which means that they have no height, no zeros. Okay, so no height. Okay, so which means that there's zero. So that's what we mean. If they have no natural zero, so like the temperature in degrees Celsius, they become interval scale. What if they have natural zero? Then they become a ratio scale. So like the weight, age, so which means that 0 years old, which means that you don't have age and all, right? You don't have, okay, something like, so you have 0 kilogram, so which means that you don't have weight. So that's what I mean by natural zero. Of course they have negative, but negative value here is uh just a direction. Okay, so we say, oh, negative 5 centimeters, so just about direction to left to the right. But again, they have a natural zero, so which means that zero means no height. Okay, so that's when usually the like interval scale like this one, we have we have negative value, but the negative value doesn't mean that uh, the value is what, like I said, it's not a natural zero. It's not. So like a ratio scale, it's about if they basically don't have negative value, but if they have, they use the negative value, which means that they just show the direction to the left, to the right. Okay, so I hope you guys understand what is nominal, what is ordinal, what is interval, what is ratio. Okay, I think this is important. Again, that's the keyword, important. Bagi you tips already lah. Come on lah. Okay, so one of the things that you need to understand also, in statistics, they use a lot of notations. Okay, this what we call the statistical notations. So the most common letter that you use is X, Y. That's the most common one. X, Y, Z, X, Y, Z, L, M, N, something like that. So that's the static the notations that they use. Okay, so X, okay, usually use to denote certain variables. So x1, x2, up to x infinity, xn. So which means that this indicate one group observation on n sample, or on that particular sample. So observation on person number 1, person number 2, x1, x2, x3, up to the up to whatever value that you want. So in general, the ith observation is written as xi. Okay, like here written as wait, I just make laser pointer here. Sorry. Okay, ith observation is written as xi, and the last one is denoted by xn. So usually this small letter n. Okay. So another the most popular symbol in statistics is especially in biostatistics in this for this course, okay, is the additive notation, so summative sum. So like using by this symbol sigma here, so which means that remember that x is the variable, so n represent the values in a sample, and also capital N represent the number of values in a population. Okay, so small n usually for the sample, bigger N or capital N, small letter n will be for sample, capital letter N will be for population. Okay. So again, I don't know why they love ancient, they love Greek. So most of the notation are from the Greek letter. So the Greek letter summation is used to indicate the sum of the n observations. So which means that if they call it as xi here, summation of xi from n to I, which means that the summation of x1 plus x2 plus x3 until the desired number of sample or the desired population. So the sample, if here what it reads is the summation of x sub I. So sometimes the summation of xi or sigma x sub I. So sigma xi, where it assumes all integral values from 1 to n is inclusive. Okay, so that's basically the interpretation. So some other notations that also used a lot, okay, in statistics. In statistics, it is summation, standard deviation for sample, for population. So you have variance, mean. What is the mean? Yeah, the mean of population, a proportion of sample size. So get familiarized with these notations. Okay, so don't worry about try to memorize. So I think this is something that is ongoing. Okay, you will learn from doing your exercises. So it's just it will come naturally. Don't worry about it. Okay, so again, I think I jump here and there on my notes. Sorry. So here is a sigma notations. So this where this upper limit, this is a lower limit. So which means that you can start from 1 to whatever. So you can start from 1 to 5, for instance. So you will observe 1, 2, 3, and 5. So this is the argument. So okay, probably I can show you the next one. Okay, so this is what we call as how it interprets. So when you call it as x1 to 5, which means that equals to x1 plus x number 2, x number 1 plus x number 2 plus x number 3 plus x number 4 plus x number 5. So that's what this means. So this the summation. Let's say we have another denotation here. Let's say square. Let's square. Kuasa 2 square lah kan? Lupa bahasa Melayu. Not square. Okay. So which means that this is the summation of x1, x2, x3, x4, x5. But if let's say that you have parentheses in this summation, you need to do the summation inside the parentheses first before you do this the other notion here, either square root or square, something like that. So this is something that you need to do. So be cautious about the parentheses, where the parentheses are. Okay, so that's for one variable. Or again, for the variable, the second variable, of course, like I said, you need to concentrate on the parentheses first. So you need to do let's say, but in this case, you can separate. You can split. Okay, based on this one. So this, if you have this parenthesis, but still in the sum of the information. So let's say this is when you have multiplication here is x1 x2, so which means x1 y1 x1 x2 y2 x3 y3 until xn x5 x5 and y5. So you need to plus everything. Okay, some of the information that we don't have, you don't use x when you do the subscript here, and you don't have just a notion. So this is no cumulative. So which means that this is just n plus k. So let's say you have k here, there's k can be outside. This is something that permanent variables that you use. Okay. So how to use the summation? Basically, when you have the xi and yi, so let's say for instance here is x summation of xi from I equals to y and n equals to 5. Okay, so for instance like this one, you have 5, so which means that x number 1 is the value is 1, x number 2 the value is 3, x number 3 the value is 5, x number 4 is the value is 7, and x number 5 the value is 9. So which means that x number 1 plus x number 1 plus x number 2 plus x number 3 plus x number 4 plus x number 5, this will become the summation of this xi. So similar to yi. So this is summation of the two. Okay, let's say you have xi plus yi. Okay, in the parenthesis summation of xi plus yi, so you need to do x number 1 plus y number 1, you get the summation of x plus y number 1. So x2 plus y2, you get the summation here, x3 plus y3, you get summation here. So same goes to multiplication. So x1 multiply times y1, you get 2, x1 times y1, you get 12, so on and so forth. And then you do the summation. Okay, that's how you do it. Okay, so let's say you have this, you get the row, okay, and then you get the sometimes they use it the single x, okay, to look at different ways to do it. So because you have various studies, right? So you have two determinations. So they call it as xij. So that's xi, which means that they have the matrix. They have the matrix that they need to look at. So which means that when you call as xij, so okay, let's see if I can say. So let's say you have xij. Okay, so depends on, you need to know that xij, so x number 1 and what j number 1, for instance. So what the value of I, what's the position, sorry, not value, what the position of I, when what position of j. So when for the follow the column is I, then follow the row is the j. So which means that when you call it as xii, then we can say one, let's say the xi number 1, I equals to 1, j equals to 1, which means x11. So this is x11. Let's say you have x3, I equals 3, j equals 4. So I equals 3, so you get I equals 3, j equals 4, so you have x34. So any value here, okay, the value inside here will be the value that represented by xij. Okay, so I'll give you an example here. So let's say when I say can you find x 2 3, so x number 1, I number 1, I number 2, okay, so this for this column. So and then you get number 3, so x number 1, j number 1, j number 2, j number 3. So x23 will be the 47, the value will be the 47. So same goes when I say what is the mark of student number 3, because this is represent the student, j represent the number of student, and then this course 1 2 3 for the course that taken by the students. You want to know what are the what they get for what the students get for specific courses. So they get, okay, so the student number 3, this is the number, okay, they get he get 72 for subject number 1, got 47, oh fail ni for subject number 2, 46 for subject number 3, 78 and then 37. Ini student bermasalah ni, kena under pemerhatian ni, under observation student. Okay, so basically these are the number of student number 3. Okay, so what is total mark? So which means that this is a summation of x I 3. So which means that 72, 47, 46, 78. Okay? So these are the summation of the students number 3. So then you can get what is the student. So this is student number 2, student number 3, student number 4. So when you get the all summation of x I, sorry, I should have my tablet ready, but I forget xij, for instance, summation of xij. So these all the summation, total summation 1597. I think this is basically quite for me it's quite straightforward. Okay, hopefully quite straightforward for you. Okay, so again this is something that what we call as I number 1, I number 2, I number 3, I number 4, and then this summation for so all for the j number 1. So this is for summation of x I for j number 1. So this is 28. So which means that if we have x I 1, summation of this one will be 28. If let's say you have summation of x 1 j is number 1, so x1 number 1, and then this so this will be 53. Okay, so this is how you can calculate.